to talk on one of the important chapter of business mathematics, that is an assignment problem. Friends, an assignment problem is also known as transhipment problem in your textbook. Before moving further to learn Hungarian Method Procedure, we'll have a light on the meaning of an assignment problem. Why assignment problem is important for the companies? Most probably the marketing department and HR department will apply assignment techniques to assign jobs to number of persons. Let me explain you an assignment problem with an example. Suppose there are n number of persons and n number of jobs. N number of persons and n number of jobs. Now the problem is, what person assigned for what job? Though varying degree of efficiency of person on one-to-one basis. So such kind of a problem is known as an assignment problem or transhipment problem. Once again I am repeating, when there are number of jobs and unlimited jobs and unlimited persons are available to perform these are all jobs with a very degree of efficiency of a person. And that situation, we think about what person should be appointed for what job. It's one of the assignment technique for HR manager, selecting the right person for the right job, providing training to those needy person, promotion to the best person, retirement to the old person, and providing adequate remuneration to all persons. So likewise here, the task of an assignment problem is to assign a job to a specific person for a specific job. So such kinds of a problem in the industry or businesses is called as an assignment problem. It is also known as transhipment problem. My today's topic is to discuss on Hungarian Method Procedure. Why Hungarian Method Procedure I am taking today? Because we need to solve practical problems on an assignment problem or transhipment problem. To solve practical problems in assignment problem, we need to understand the Hungarian Method Procedure. There are the conditions. Condition number 1, condition number 2, and there are steps 1, 2, 3, 4, 5. It depends upon the problem given. Right? Now, let us shed a light on the condition number 1 of Hungarian Method Procedure. What it says. See here, you can read out condition number 1. First of all, we have to prepare a cost matrix. What is cost matrix? See, the objective of any organization is to maximize the profit, not minimize the profit. Maximization of profit or maximization of wealth. When it is possible, then you minimize the cost. So, our matrix should be cost matrix. If it is profit matrix, we cannot proceed with the Hungarian Method Procedure because it reduces the profit. Ultimately, our objective or intention is not to reduce or deduct profit. Hence, the condition number 1 says we have to prepare a cost matrix. Prepare a cost matrix. If a given matrix is a profit matrix, then convert profit matrix into a cost matrix by selecting highest cost and then subtracting with other elements, entire elements. The new matrix is set to be a cost matrix. Try to understand what it indicates. It's all about converting profit matrix into a cost or loss matrix. Correct? To convert profit matrix into a cost matrix, we have to select the highest element in the matrix and subtract with other entire elements. The new matrix, what you create, what you prepare, it is called as cost matrix. Let us understand this condition number 1 by an example. This is an example and this is converted into a cost. Correct? Fine. Now see, profit matrix is given for you and you have to convert this profit matrix into a cost matrix. Now how to convert it? See, there are three jobs, job A, job B and job C. Likewise, see the word persons, person A, person B and person C. See the profit 40, 45, 48, likewise 40. Right? So how to convert? We have to select the highest element, the profit or number. The highest number is 90. If you want, you can check 40, 45, 48, 56, 68, 90, 85, 45, 40. 90 is the highest element in the matrix. Now we have to select 90 and subtract with other elements. See here, 90 minus 40 is nothing but 50. 90 minus 45, 45. 90 minus 48, 42. 90 minus 56, 34. 90 minus 68, 22. 90 minus 90, 0. 90 minus 85, 5. 90 minus 45, 45. 90 minus 40, it is 50. This is nothing but the conversion of your profit matrix into cost matrix by selecting highest element in the matrix and subtracting with other elements. The new matrix is said to be a cost matrix. This is the condition number 1 of Hungarian method procedure. Well friends, the second condition of an assignment problem is we have to prepare a square matrix. So what is square matrix? Width equal to length. This is called square matrix. Width equals to length. Such type of matrix is called as square matrix. For example, when there are 4 rows and 4 columns, such matrix is said to be a square matrix. Likewise, 5 rows, 5 columns, 6 rows, 6 columns, such matrix is called as square matrix. Suppose the given matrix is not square or unsquared, we cannot proceed because condition number 2, it is clearly said, convert unsquared matrix into a square matrix. See here, prepare a square matrix. If the given matrix is unsquared matrix, convert unsquared matrix into square matrix by adding dummy row or dummy column. I just explain you the conversion of unsquared matrix into square matrix. So friends, please have a look with example number 1 here. See, the jobs are available and the persons are available. The job A and job B, persons are person A, B and C. If we check the rows, there are 3 rows. Row 1, row 2 and row 3. If we verify the columns, there are only 2 columns. To make this unsquared matrix into square matrix, we add a dummy column A, B, C with 0 cost element. Which cost element? With 0 cost element. This is the conversion of unsquared matrix into a square matrix. Now you can see there are 3 rows, 1, 2, 3 and there are 3 columns, 1, 2 and 3. This is nothing but the conversion of unsquared matrix into square matrix adding the column. Now here there is another example called example number 2. Say the jobs are 3 here. Job A, job B and job C, but the persons are 2, person A and person B. Again it is said to be an unsquared matrix. To make it square matrix, we have to add dummy row, dummy person C by 0 cost element. Correct? Now it is nothing but the conversion of unsquared matrix into a square matrix. So this is the example to understand the condition. Condition number 1 and condition number 2 completed. Next we move further to the real steps of Hungarian method procedure. Friends, now it is time to learn the main steps of Hungarian method procedure. The step starts when you convert profit matrix into a cost matrix and again prepare your square matrix if it is unsquare matrix. What step number 1 says here is we have to select smallest element in each row and subtract with other elements one by one row wise. This is the step number 1. This is not condition number 1, but it is step number 1. See what our condition says, step says select smallest element in each row and subtract with other elements one by one row wise. So first of all we have to check how many rows are there. There are 3 rows, row 1, row 2 and row 3. Okay, let me go with row 1 first. Select the smallest element. The smallest element is 3. So subtract with other elements. 6 minus 3 equals to 3. 3 minus 3 equals to 0. 5 minus 3 equals to 2. This is row 1 successfully completed. Now the second row, person B, the smallest element is 2. 2 is the smallest. Now we have to subtract. 8 minus 2 equals to 6. 2 minus 2 equals to 0. Then 4 minus 2 equals to 2. So likewise, the last row is 5, 9 and 4. 4 is the least. 5 minus 4 equals to 1. Then 9 minus 4 equals to 5. Then 4 minus 4 equals to 0. This is step number 1. Not condition, but step number 1. Step number 1 will start after condition number 1 and condition number 2. Once you fulfill condition number 1 and condition number 2, you apply step number 1. Step number 1. Select the smallest element in each row and subtract with other element one by one. It is said to be step number 1 of Hungarian method procedure. So friends, now the step number 2 of Hungarian method procedure is we select the smallest element in each column and subtract with other elements one by one, column wise. Earlier it was row wise, now it is column wise. Then let us understand with an example here. So this is an example and this is the conversion of solution, you can say. See, again the jobs and person ABC and ABC. So we have to select the smallest element in each column and subtract with other elements one by one, column wise. So if it is column wise, we have to look all the 3 columns. Okay, then we select the first column first. The smallest element in this column is 5. 6 minus 5 equals to, it is 1. 8 minus 5 equals to 3. 5 minus 5 equals to 0. Likewise, the second column, the least value, the smallest value is 2. 3 minus 2 equals to 1. 2 minus 2 equals to 0. 9 minus 2 equals to 7. Likewise, the third column, the least value, there are 2 least values. Either you select this 4 or this one. Okay, 4 is 4. Okay. 5 minus 4 equals to 1, 4 minus 4 equals to 0, and 4 minus 4 equals to 0. This is step number 2 of Hungarian method procedure. Selecting the smallest element in each column and then subtracting with other elements one by one, column wise. Right? This is all about step number 2. Step number 3. We draw a minimum number of lines to cover all the zeros, horizontally or vertically. What step number 3 says? Draw a minimum number of lines to cover all the zeros in the matrix. Right? We'll understand this by one example here. This is our matrix. There are job ABC and persons. Sorry, it's machine. Machine A, machine B and machine C. See, we have to drive to draw minimum number of lines to cover all the zeros. It depends upon you how you try. Correct? Fine. And let us solve step number 3 by this example here. How many rows are there? 3 rows and 3 columns. If I draw a line here in the first row, I cover only 1 0. If I draw here, I cover 1 0. I cannot draw a line here because there is no 0 and there are no zeros. If I go with the column, I cover 1 0. Second column, I cannot draw a line because there are no zeros and there is no 0. Likewise, third column, there is 1 0. So, better I draw the line here. 1 0, 1 is, and the next 0 here. I have drawn two lines. Only 2 lines. So, N, capital N means number of lines drawn. And small n is denoted by order matrix. Our order matrix is 3 into 3. It means small n equals to 3. Number of lines drawn 2. So capital N equals to 2, small n equals to 3. So capital N is lesser than small n. Number of lines drawn lesser than the order matrix. Hence we have to proceed with next step. Step number 4. Unless we get n equals to n. Correct? So this is all about step number 3 of Hungarian Method Procedure, my friends. So well friends, now the step number 4 is all about select smallest uncovered element and subtract with other uncovered element and add to the intersection point. Just line drawn as it is. Let me explain to you this step number 4 with an example here. My example is ready. We have to consider the previous step number 3, the values for step number 4. That's why I am considering this step number 3 solution for step number 4 here. Right, friends, see what it says. Select the smallest uncovered element. Now we need to understand what is uncovered element in the matrix. What is cover elements in the matrix? What is intersection point in the matrix? What is the line drawn in the matrix? The 4 questions we need to understand. Uncovered element, covered element, intersection point, and the just line drawn. Right? See, here in the previous solution, uncovered elements where the line is not drawn. Such numbers, such values, such elements are called as uncovered element. See, if you look here, 3 is uncovered where there is no line drawn. 5 is uncovered, 1 is uncovered, 4 is uncovered. Likewise, 0 is covered element because the line is drawn on 0. Likewise, 5 is covered element. 2 is covered as well as intersection point, but we have to consider intersection point, the cross point. See here, 1 line and second line, intersection lines. So here we have to add the intersection point. I will explain you in the solution. I am just telling here covered element, uncovered element, intersection point, and just line drawn. These are the uncovered element, these are the covered element, and this 2 is intersection point. So according to step number 4, we select uncovered element. Which element? Uncovered, smallest uncovered element. So smallest uncovered element is 1. 3, 5, 4, 1. But the smallest one is 1 here. So we selected 1 and subtract with other uncovered element. Other means these are the 3 other uncovered element and add to the intersection point. There is only one intersection point here in this question. If multiple intersection points will be there, you need to add to all intersection point 1. Right? Okay, let us solve with an example. Fine. Come here. So first one is just line drawn, you write as it is. The second one is just line drawn, you write as it is. This is intersection point smallest uncovered element. 2 plus 1 is 3. Likewise, so 3 minus 1 is uncovered element. So we have to minus smallest uncovered element with other uncovered element. So 3 minus 1 equals to, it is 2. 5 minus 1 equals to 4. For 0, it is line drawn. We keep as it is. So 1 minus 1 equals to 0. 4 minus 1 equals to 3. And 5 is as it is because it is just line drawn. So these are this one condition we need to fulfill in case of step number 4. We select smallest uncovered element and subtract with other uncovered element and add to the intersection point wherever line drawn we keep as it is. So this is all about step number 4. So well friends, due to non-equality between number of line drawn and the orthogonal, we need to proceed to the next step number 5. It says all about from the modified matrix we again draw minimum number of lines to cover all the zeros horizontally or vertically. The same previous step we need to apply again for loop 2. Here we'll understand this step number 5 with a continuation of the example. We draw minimum number of lines C to cover all the zeros horizontally and vertically. I already explained you in the previous example. So if I draw here, I cover 2 zeros. If I draw in second column, so we cannot draw because there are no zeros. Okay, there is no zero. In the third column, I could find only 1 zero. First row 1 0, second row 1 0, and the third row also 1 0. But maximum zero I am covering here in the first column. So 2 zeros I have covered by drawing one line. So likewise, I again state a draw like this. So again, the n equals to 2, but order matrix is 3. Again, small n is lesser than. Sorry, capital N is lesser than small n. The number of lines drawn lesser than the order matrix. Hence, we need to proceed with the next step, my friends. Next step again is step number 6. Friends, now we proceed with step number 6. Again, the step number 6 says select smallest uncovered element and subtract with other uncovered element and add to the intersection point. The same step again is repeated. This is nothing but the loop 2 I said already. So here we have already drawn 2 lines. Okay, this is called covered element, uncovered element, and there is no intersection point. You know, wherever line 1 we keep as it is, uncovered element we minus smallest uncovered element, and the intersection point adding because there is no intersection point. We easily proceed with an example. So this step number 6 we will understand by my example here. See, so first one is 0. So 0 line drawn, 2 is line drawn, and 0 is line drawn. Just line drawn we keep as it is. So we paste 0, 2, and 0. Now the 5, the least uncovered element is 3. 5 minus 3 equals to 2 here. Then 4 minus 3 equals to 1, and 3 minus 3 equals to 0. Likewise, 3 as it is, and 0 as it is, and 5 as it is. This is all about step number 6, my friends. Step number 7 now. The step number 7 says, from the modified matrix is again third loop. We again draw a minimum number of lines to cover all the zeros horizontally and vertically. We have to try to draw minimum number of lines to cover maximum zeros. Let me try with this example. See the zeros 1, 2, 3 and 4 zeros are there, and I am trying to cover all the zeros by minimum number of lines. See, if I draw the line here, I cover only 1 0. If I draw second row, 1 0. If I draw here in the third row, 2 zeros will be covered, and here first column 2 zeros will be covered. Second column only 1 0, and the third column 1 0. So let us draw either column side or row side. first I draw a line, 2 zeros covered. See, now the second if I draw like this, I cover 1. 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 So I cannot minimize the number of lines to 2 here, because the maximum the line I can draw for a minimum line is 3. Here the number of line becomes 3, and the automatics is also 3. We have to stop here. We have to stop here in step number 7, because the capital N equals to small m, the number of lines drawn equals to the automatics. Again we proceed to the step number 8. We select a row with single 0 and make an assignment in such a way that no other job should be assigned. This is the step number 8. Select a row with single 0 and make an assignment in such a way that no other job should be assigned. So here your example is ready. So let me explain you. So first of all, we select a row with single 0. There are 3 rows and I will find a single 0 here. Here also I have got a single 0, but here there are 2 zeros. But first preference goes to first row, and I'll make the assignment and I'll check right side, left side, above and below. If there are any zeros, we have to cancel. Okay, on right side there are no zeros, or there is no 0, and there is no left side top. So we can see here downside there is 1 0. We have to cancel. Okay, all the sides, right, left, upper side and lower side. So if you could find 1 0, cancel it. So I have already cancelled, and again I could find single 0 in the second row. I'll make an assignment, and again I'll check whether there are zeros or not. So there are no zeros. Okay, and obviously the last row is this. I have made an assignment, assign. There are no zeros remain. There is no 0 remain. This is nothing but the exact assignment, and your assignment is absolutely correct assignment. So likewise, you go to your question and assign here 1 1, and assign here CD and assign BC. Likewise, we will find the total cost of your assignment problem and the job sequence. So job sequence is nothing but A to A and B to C and C to B. This is the job sequence. If you see in your textbook, you could easily understand how to calculate the total cost and how to find out the job sequence. This is all about your Hungarian method procedure, my friends. Basically, 2 conditions are there and remaining number of steps. The steps may increase or decrease, depends upon the nature of problem given. So this is all about one of the important chapter, assignment problem, or you may say transhipment problem. Under that, Hungarian method procedure for your practical problem. Once you understand this Hungarian method procedure, entire conditions, entire steps, you can easily solve the entire problems of assignment problems or transhipment problem, friends. So please keep practice in your home so that you perform better in your upcoming examination. So please guys, and stay home, stay safe. Thank you.